This is an example calculating a partial molar quantity given the molar quantity of a solution. So binary solution will make things dimensionless just for ease of calculation. And the partial molar quantity, this could be enthalpy or volume, is 6 times the mole fraction of component 1 times the mole fraction of component 2. We want the partial molar quantity of component 1. So the approach is to directly do the differentiation by going back to the definition, partial molar quantity. So a couple things that are important here. It's the number of moles times that partial molar quantity. So this value here is per mole. So multiply by the total number of moles, and we're going to differentiate with respect to the number of moles of component 1, where we keep the number of moles of component 2, not the mole fraction, but the number of moles, and also the temperature and the pressure is constant. So if we're going to make this substitution, we have 6 times n, and I'm going to write the mole fraction as 1 over n and n 2 over n. This is what we're, let's give ourselves a little more space. This is where we're going to take the partial derivative with respect to n1. So just to make clear what we're taking the partial derivative, I'll bring the 6 out front. It's n1 times n2 divided by n. And I won't write every time, but remember we're keeping n2 constant, keeping temperature constant, we're keeping pressure constant. So that means I can rewrite this as 6 times n2, the partial of n1 over n, respect to n1. And then I'll use the product rule to do the differentiation. So I've written out the product rule here. I'll keep n1 constant and differentiate 1 over n, and then I'll keep 1 over n constant and differentiate n1. So this derivative is 1. This derivative, we have to use the fact that n is equal to n1 plus n2. And so the derivative of 1 over n respect to n1 is going to be and so doing the algebra and using the definition of mole fraction simplifies to this, which we could simplify further. 6x2, 1 minus x1 is x2, so the partial molar quantity component 1 has this dependence on the mole fraction. So the important things to keep in mind is that we have to work with the molar quantities, not the mole fractions, when we're doing this differentiation.